Let's look at completing the square in our study of quadratic functions. We've already seen that when a function is in vertex form that we can tell about its graph. But sometimes when we want to solve equations where there's not a y but there's a 0, we can use a method called completing the square to solve the equation. And there are times in advanced math when we have to do this process called completing the square. So this program is foundational for many, many topics in math as we go along. But our first use of it will be to find the two values for x, even when our function cannot be factored. Let's just look at this one. See, there are not two numbers that multiply to give us 10 and subtract to give us 12. There just aren't. So this cannot be solved by factoring. So there must be some strange value that x is worth. It must have a radical in it or something. So what we have to do is learn this process called completing the square. And I'll try to explain it one step at a time. I actually put steps in here. That's why I have these footprints. You click step 1 and it will tell you what to do. Add the same number to both sides of the equation so that the constant term will be removed. So the constant term is this negative 10, so in order to get it off of this side, I would have to add 10 to both sides. Hope you see that? Add that to both sides. And now we have x minus 12x with a scroll bar here equals, and the 10 is now on the other side. Now we have to learn how to complete the square to make it into a perfect square. Decide what number needs to be added to the x squared and x to the first power term to make it a perfect square. So I'm going to show you how to do that. I'll bring up the marker. In order to find out what has to be here so that our quantities will be a perfect square, that would be in this case an x minus and an x minus, we have to find what number needs to be added here to make these two terms into a perfect square. We have the power, so I'm going to teach it to you. To find out what these two things need to be perfect, oh, don't we wish we had a formula like that for life. What you have to do is take the number in front of the x, don't worry about whether it's positive or negative. Take the number that's in front of the x, divide it by 2, that gives us 6, then square that. These two things need a 36 to be perfect. That's all they need. We could give it to them. Now we have to follow the rules of equations, though, that if we add 36 to this side, we would have to add 36 to that side. I'm going to minimize, get this marker out of the way. Just remember, these two guys on the left need a 36 to be perfect. So we'll give them a 36. Why not? And now we'll bring up the marker and see what, oh, well, first we'll check this button. It says, I think that makes it perfect, just to make sure. It does make it perfect. So now what we have to do is we have to factor the trinomial. So I'm going to bring up the marker here so we can talk about factoring this. We want to factor this trinomial. It's going to be a perfect square because we gave it what it needed to be a perfect square. So this is really kind of easy factoring. The two quantities have to be exactly alike. So 36 is going to come from 6 and 6. This is a plus. We always add. So we look next door. Both of these have to be minus. If you double check, x squared minus 12x plus 36. This factors down into x minus 6, the quantity squared. Get rid of the marker, and we will factor this down into x minus 6, the quantity squared. So this is equivalent to this. The 46 is still with us. Now we'll take the square root of both sides. Ba-dum. We'll put a plus or minus on one side. We don't need to put it on both sides because that'd be kind of redundant. Now if we ask ourselves what number times itself gives us this thing squared, it's just going to be x minus 6. I hope you see that. And we have the 46. So our last step is going to be subtract the constant term, which would, in this case, it would be adding 6 to get the x by itself. So we will add 6 to both sides. And now this is the solution. Strange as it might be, there are two answers to this equation that would actually make these things equal to 0. And that would be 6 plus radical 46 and 6 minus radical 46. I won't torture you by making you test it. Let's do another one. This one would be actually factorable. We could factor it, but let's see what happens when we complete the square. Step 1, get this extra term out of the way. So we would do that by adding 5 to both sides. Now we just have these two, and we have a 5 over here. Now we need to see what would make this perfect. Now remember the formula. Look at the number that's in front of the x. Divide it by 2. Now we're to 2. Square that. These two guys need a 4 to be perfect. So I think that makes it perfect. It does, because see, this is going to factor down into x minus 2 times x minus 2, and this is going to be a 9 over here. X minus 4, this is going to factor down into x minus 2 squared. I hope you see that. And this is 9. Take the square root of both sides. Oh my goodness. The square root of x minus 2 squared is x minus 2. Radical plus or minus square root of 9. This is going to be 3, so it's minus 2. Oops, I'm sorry. We're going to add 2. And now we get 2 plus or minus radical 9 is our solution. But radical 9, we know what that is. It's 3, so it's either 2 plus 3, which would be 5, or 2 minus 3, which would be negative 1. Now, if we had factored this up here and solved it by factoring, we would have gotten the exact same numbers. Isn't that weird? Let's do another problem. We need to get rid of the 12. We're practicing completing the square, so we'll add that to both sides. What do these guys need to be perfect? Get automatic here. Half of 6, 3, squared is 9. It needs a 9 to be perfect. We'll add that to both sides. I'll add then the 12 and the 9 for you to get the 21. This will factor into x plus 3, the quantity squared. Take the square root of both sides. This time, we can't get a natural number, which means that this thing was not factorable. So next, we have to get rid of this 3. So we'll subtract 3 from both sides. We get x is equal to negative 3 plus or minus radical 21 for its solution. Maybe one more. Two numbers that multiply to give us 8 and subtract to give us 12? I don't think so. So we can't factor this. We're going to add 8 to both sides. We're going to figure out what makes this perfect. Half of 12 is 6. It needs a 36. Get good at it. I think that makes it perfect. Now we're going to factor. This is going to factor into x plus 6. Take the square root of both sides. We can subtract 6 from both sides. And we have some simplification to do. Because the negative 6, we can't do anything with that. But this 44, the 44, this is really 4 times 11, and the 4 could come out as a 2. Radical 11. I hope you've studied the simplification of radicals. Check, we win. If you didn't, you could look at the radicals program and see how to simplify radicals. I hope that program is done. Thanks. This is completing the square. Oh, find out more about perfect squares. I've been careful to give you something that was just when you take half of this number, it's always turning out to be an integer, but things could get more complicated. If this number were odd, you're going to find out about it here. Oh, step 1, it's the same. We're going to, wait a minute. In this section, you only work part of the problem. You'll have to go, we have to read this box before we can go on. In this section, you will work only part of the problem. You will go step by step until you find out what makes it a perfect square, because it would have gotten too long for me to put all the possibilities. First thing we're going to do is we're going to subtract 2 from both sides and end up with this. What do x squared and 7x need to be perfect? Half of 7. Don't give me 3 1/2. It's 7 halves. 7 halves squared is 49. 2 squared is 4. This is what it needs to make perfect. We're correct. See, it's only taking us that far to figure out what it needs to be perfect. Let's do a couple more of these. We're going to add 11 to both sides. Now we need to figure out what x squared minus 11x need to be perfect. Take half of 11, but don't do the arithmetic. Just think of it as 11 halves. 11 halves squared is 121. Over 4. I think that makes it perfect. 11 halves squared, that makes it perfect. We're right. One more. Add 4 to both sides. What do x squared and 3x need to be perfect? Half of 3. Don't do the division. It's 3 halves. Keep it as a fraction. Half of that squared is 9 fourths. Get in the habit of staying with the fractions. They are your friends. Fractions are your friends. You'll need it for when we study conic sections, which is a lot of fun. Why? Because then we can go on expeditions to Mars and Jupiter and whatever.